Hello everyone, welcome to my YouTube channel GIS and RS Depot, platform of GIS and Remote Sensing. So in this video, I will try to show how you can easily calculate any water body area or estimation of any water body area or any lake area. So that's why we first of all we select our study area. So for in Google Earth Engine Map Interactive View, first of all we select our study area as a four vertices or any shape of this study of our study area. So for that, so simply go to this area. Okay, so you see here, see this is the lake shape file or water body um, available in this area. Okay, so for that, so first of all we select our study area. For that, we go to our draw a rectangle tools and select our study area which we want to calculate this study area shape file or this study area calculation estimate this area. So already we put here this study area. Suppose we change this study area name region of interest ROI, and after that I download any satellite data set, suppose Landsat or Sentinel. So if you want, you can use Landsat or Sentinel. Just search here the Landsat, and when you search Landsat, lots of the Landsat data set available here. You see the USGS Landsat 8 collection to tier 1 top atmospheric reflectance data set, Landsat 9, Landsat 7, lots of data set. From here randomly we select this Landsat 8 data set for this study. So you see here the Landsat 8 top atmospheric reflectance data set, description of this data set, also band information of this data set. So now we import this data set in our code editor. So that's why simply click on the import option, import button, and import in our code editor. So now you see here the image collection. So as a Landsat 8 image collection, this the data set already input in our code editor. Okay, so now we step by step we filter our study area, filter our time frame, then also we calculate this study area lake shape file or water body shape file estimate area. Okay, so first of all we make a layer of this study area. Suppose map dot add layer from Google Earth Engine docs tab, all of the function available in docs tab. Okay, so study area geometry or object, our object is ROI because we select this study area as our interested part of this study. Okay, so not necessary thing, simply remove from here and then we click to the run. When you click to the run, you see here the new layer open. Layer 1 is open in our um, study in our map interactive view. Also you see here this area. Okay, so this area we see as a layer. Here you see the lots of water body and also land area available. From this area we calculate this water body or lake area we estimate. Okay, how much area or what how much area of this study location. Okay, so after that, so we first of all we select our time frame. Okay, so this data set available time, you see here the year of 2013 to present time, year 2024 October. So also all of the things, all of the band combination of the data set available here, B1, B2, B3, B4, and all of the coastal aerosol band, blue band, green band, okay, red band, all of the band available here. So now we filter this data set. So first of all we take a variable. Okay, so if you want, first of all, you take a variable. Variable name is image for filtering image, and then we call our Okay, this is the one. Okay, we another way we follow. So we take a variable, and first of all we select a time frame. Okay, suppose start time start and time end. Okay, start time and end time. Start time we select suppose year of 2015, and also end time. Start time we select year 2015, and also we select end time year of 2017. Okay, 2 years we select for this study area, for this study. So if you want, also you can use single quotation or double quotation for this part. Or if you had the start time also year 2015, and end time is year 2017. Okay, so then also we call our image collection of this Landsat 8. So we take a variable name is, we select here the Landsat 8. Okay, this variable is Landsat 8. So that's why we put here the Landsat 8 for better understanding. And then we call our study that data set variable name is image collection. So simply copy and paste here this image collection. Okay, then we filter step by step our study area, then filter date function. Suppose we first of all we selected the filter date function. Filter date, in time date and start date. Okay, in date start date already we select here the start time. I put here this start time year of 2015. This start time indicate the year of 2015. Start time we put here, and end time also year of 2017. End time simply copy this variable name and also paste here. So start time and also in time we select. So then we filter our specific metadata, specific our time frame. Okay, so suppose it's already we select our specific time frame, and now we select only filter a metadata. Okay, that means how much amount of cloud or haze particle we access for our filtered images. So that's why we use at the filter. Suppose filter function, and dot filter metadata function filter. Okay, filter, suppose we use at the filter less than. Okay, filter less than, suppose this image properties is cloud cover. So we filter only less than 1% or less than 5% or less than 10% for better analysis. So that's why we first suppose filter less than 10%. If you want to check how many images available for this time frame, so just use here the print function and call this filter. From this data set, whole data set, only we select 2 year and less than 10% images of whole data set. So and I if that the click on the run, we see the image collection is computing for show as a round figure number value. We show you the use the size function, and now you see here that this all total data set image collection is okay, more than 1 lakh images available this time frame year 2015 to year 2017, and also less than 10% from this image. We also only filter our specific month or a specific time. Okay, so somebody there, that's why another filter function we use here, the suppose filter. Okay, filter again we use the filter dot filter function. Again, all of the function available in your docs tab. Okay, sorry. Okay, dot filter, all of the function available in Google Earth Engine docs tab. So that's why you search all of the function in your docs tab of Google Earth Engine code editor. So that's why we, for the first of all we selected the dot filter function, and also another filtering function calendar range. Okay, calendar range. Okay, our function is working. Calendar range. Okay, suppose we filter only a specific month. Suppose a specific month. Suppose 6, 9. Okay, 6, 9. This month. Okay, 6, 9 or 5, 9 month. Okay, that means date, also date, month. Okay, all of this, lots of the filtering function available in step. So in this time we use at the filter calendar range function, so as to the 6 to 5 to 9 months. Okay, we put here the we indicate the months. Okay, so now if you want to filter, click to the run. Now you see they have the number of images is decreasing. Okay, from more than 1 lakh images, you see here the only 50 thousand images already we filter. Then we filter our specific specific our study area. Okay, for that we use here the, suppose we use here. Okay, for that we use here, just we use here our study area. Okay, we use here the filter bounds function. What is a filter bounds function? Filter bounds function only indicate our specific location or specific study area. Filter bounds when you place control and space, you see here the geometry. What is our geometry? Geometry is our specific study area, ROI. Okay, so that's why we, when we attach this study area geometry, now we fill this filter bounds function only or only uh, only access our this study area part. Okay, this study area is small study area, and dramatically you see the other number of images collection is decrease. Okay, so now click the run. So now you see here the only 3 images available. Okay, for this study area, only 3 images available in my study area or in our this study area part. Okay, so that's why we use here this type of use are this type of function, filter bounds function, that filter date specific time frame 15 to 17. Okay, then we use here the filter less than this image properties. From this image properties, cloud cover means the percentage of the cloud in available in these images. That's why we use the cloud cover less than 10%. And also we filtered calendar range of, if you want to, if you want you can also mm, remove this one filter function. Now we see the 26 images available. Okay, only 26 images available. But when you use this filter function calendar range, so you see the only 3 images available for this months. Okay, so now we go to another part. So also we only this images is less than 10% cloud pixel percentage, only 3 images available. And after that we use here the, we take a function and calculate our any water quality index, suppose NDWI, MNDSI, or anyone. We first of all we make, and then we estimate our water body, and also we put here the threshold value of water body. Lots of the things we complete step by step. So okay, now we see here the, suppose we take a function. Okay, we take a function, and function variable name, function element name, we use here the image. Okay, if you want you can use any variable name, no problem, or element name. So image, and then we make a curly bracket start and curly bracket end, and we calculate our all of the things. Suppose we take a variable, and variable name is band. Okay, band, and also we put here the this satellite data set supplied band name. You see here the B12, lots of the band available. So that's why we put here the any list of the band. Okay, so when we put the list of the band, just we also put here the select of the band name. Okay, so we put here the we call our variable name just image img, and also put here okay, for better understanding, skip one line. uh, Okay, now we see here the band's image. We use the select function for selecting the satellite dataset band. Okay, so now we put here the all of the band. If you want, you can use make the band list. Suppose we put here the B1 band, then we put here the B2 band, B2 band, then we put here the B3 band, B3 band. Okay, B3 band. Also we put here the B4 band. Also put here the B5 band. Also we put here the B6 band. Okay, it is the another way, one way. Another way, just we put here the B1 and also the start sign, and also automatically all of the band put here. So I use this one B2 B for this any water indices calculation need to B3 B5 B6 this type of band. So from that we remove this B2 B2 band B3. Also we put here the B2 B3 B4 and B5 B6 also. Okay, so now we take the another part. So now we put here the calculation any indices, suppose ND WI ND MND WI. Okay, so now we put here the NDWI only. NDWI means normalized difference water index NDWI. So then we use here the call this our the band's name. Okay, band's name, all of the bands already we put here the band's name called the bands. And also we put here the normalized difference function, normalized difference function. This normalized difference function automatically calculate or automatically calculate the bands of this which band we access. This normal difference band automatically calculate first band minus second band divided band, first band plus second band. This band normalized function automatically calculate our two band and make a result of NDWI. So normalized difference band, and we also put a list of the two band. So for NDWI, we know B3 that means green band, and for this data set, for this Landsat 8 data set, B3 indicate the green band and also B5 indicate the near infrared band. So when we calculate the NDWI, so we need B3 and B5 band, that means green band and near infrared band. So that's why we put here the only two band. Okay, only two band, B3 band, simply copy, and also we put here the B5 band. Okay, these two band required for calculation calculate NDWI. Okay, so already we put here the this type, and also we rename this band name, band name rename is, suppose we put here the NDWI band name. Okay, no problem. If you want, you can use anything. So NDWI. Okay, also must be use single quotation or double quotation because it's string. Well, okay, so also we put here this band name, and also we, if you want, we use here the return function. Okay, return return this function, return this all calculated NDWI. Okay, return this NDWI, simply copy and paste here NDWI, and also copy properties, also copy this image, this NDWI we calculate for only one images, but you see here the for only one images or only for any time frame images. But you see here the total time frame images, you see here the three image available. So that's why we use here the copy properties function, copy properties function, and copy this function for all of the images. Okay, copy properties, so P is capital, so copy properties function. Okay, copy properties and call our band variable name, sorry, function element name is image, copy properties name is image, also we put here. Okay, also put here, and then we we put here the this same images and use here the property names function. Okay, property names function, sorry, property names function, property, okay, property names function we may mention for this. Okay, so now we make this type of function also we make, and so now we make a median composite. Okay, median for these three images we make a median composite images for this. Okay, at a time we all of the things we make in our in this function. So median composite images for all of the images we make. That's why that means this from three images we make a only median composite one images for this analysis. That's why we put here the median function. Okay, so median function, and also okay, also maybe pass bracket. uh, okay, so no problem, wait a minute. What is the problem? Okay, so after some time we'll solve it, don't worry. So median composite images, also this function, when this function we attached in our filtering function. That's why we use here the map function, dot map function, and this function attached in our when we use here the map function, this filtering function, all of the filter, all of the filter, and also this ndwi we already calculate and attached in our filtered images. That's why we use the map function, and this problem we solve already, so no problem. And now we make a map layer, suppose map layer. Now with this ndwi or this filtered ndwi calculation we make as a map layer. Okay, suppose there now we use the map dot add layer function, map dot add layer function, and also object name is Landsat 8, because already we filter all the things and put here the Landsat 8 also put here. And also we some after some time we select the visualization. So if you did not set any visualization, just we put here this type of things. Wait a minute. So okay, so now click to the run. So now we see here the one that size function is not working because we make a median composite image. That's why we remove this size function. And now you see this type of uh, images for this total whole area. Now we only clip our study area, so that's why we use here the clip function. Okay, clip our study area in this layer, or if you want you can use another thing here. If you want you can this clip function you use here. Okay, so no problem. So now is ROI, region of interest. Our clip function is region of interest, and then we all the things are same. Okay, now we click on the run. So now we see the two layer. You see here the okay, two layer. You see here this is the one is, wait a minute. So one is a study area layer, and another is our this ndwi ndwi calculated layer for this study area. Okay, so suppose this layer name we set here, layer name, suppose we layer name set here any we did not set any visualization. That's why we put this type of things. We did not set any visualization. And also we make the layer name, suppose layer name is nd wi. Okay, now click to the run. Now you see this layer name is ndwi. We show here the layer name is ndwi. Okay, now we apply the threshold technique for this ndwi. That's why we use the map dot add layer function again. Map dot add layer function. Map.add layer function, and also object name is also same things. We put here the Landsat 8, and also we clip our study area at a time, clip, and then visualization and geometry, and also we put here the threshold value. This is a greater than 0. Okay, greater than g0. This we put here this type of things. And visualization, we did not set any visualization for this. We curly bracket is curly bracket in, and name this layer name is, we put here the suppose ndwi threshold. Okay, ndwi the threshold. Okay, and the threshold, and also other things we simply remove. And now click to the run. Problem. Okay, not greater than gt, greater than 0. This function is greater than 0. And now we click on the run. So now we see here the another layer is ndwi threshold layer. Okay, ndwi threshold layer. So if see here that means this threshold layer greater than 0, all of the values where the water body, this type of this water this in this you see here this the total of the ndw of this study area, and from this the thresholding just we should max only or apply on only our water body. You see here this only this water body show here this type of color. So now we if you want to check, suppose we take another variable name is threshold. Okay, threshold, and also we call our filtered images sentinel 5, sorry, sentinel Landsat 8, and also we use here the greater than 0.1. That means all of the greater than 0.1 value indicate all of the water body. Okay, 0.1, and then we marks it. Okay, then we marks it, take another variable, marks this threshold, and threshold call this threshold value, and you use here the update marks function from Google Earth Engine doc step, update marks function, and put here this threshold. Okay, I will click the run. So when we make a layer, then we see it. Okay, don't worry. So now we see here the take a map dot add layer, map.add layer function, and also we put here the call this masked. Okay, masked of the threshold and the water body ndwi. Okay, and then we visualization we did not set, that's a curly bracket start and curly bracket in, and name this layer is suppose ndwi masked. Okay, ndwi ndwi max, and also something else we remove. Now click to the run. Now see this layer of the NDWI marks, also one of the NDWI and NDWI threshold, and also NDWI marks layer. Wait a minute, so same things. Okay, so you see also the surroundings area also marks this NDWI. Also here the NDWI surrounding area water body also marks by using this function. Okay, so just we calculate this water body estimation of this water body area. Okay, estimate this water body area. So now we go to another line of code. So now we use here the area calculation of this water body or lake shape lake body or lake shape file or water shape file. Okay, so now we take another function. Okay, that suppose we area. Okay, area we calculate this area. So we call area and we call our masked area, that this masked threshold area. Simply paste here, and then we use here the then we apply here the um, then we apply use the multiply marks multiply with this function one function e dot pixel size image pixel area e dot image pixel area. Okay, this function automatically calculate as a square meter. Okay, pixel area, this function automatically calculate as a square meter. Okay, so after some time we will see it. So now we make a layer. Okay, map dot add layer, map dot add layer function, and also we sorry I miss capital map dot add layer function, and also we put here the area. That means also we marks area, we use here the image dot pixel area function. This function automatically calculated this masked area as a square meter. So we simply copy this variable name area and paste here, and also clip our study area, also clip our clip function as our study area, clip ROI, that means region of interest already I said, and also uh, visualization we did not use here anything. Okay, also, and then we name of the layer name. Suppose layer name is we put here the ndwi area. Okay, if you want you can use any name, no problem. Ndwi area, and also all the things are we remove. Okay, so now click the run. So now you see here this another layer is ndw area. That means which area we want to calculate of this water body, only this water body we calculate this area. Okay, this water this layer already we see, you see. Okay, so now we put another function. Suppose this lake area we want to calculate. Now calculate, suppose take a variable name. Suppose variable name is we take a lake area or lake area. If you want you can use any variable name, no problem. Lake area, and also we use here the area. Okay, call this area. Also we put okay, if you all the put area. So okay, so now we call this area, and also we use here the reduce region function, and all of the all of the item we fulfill step by step. So make a dictionaries, curly bracket start, and also curly bracket end. Okay, so now we reducer. What is our reducer? Reducer we select as a e dot reducer dot main function. Okay, e dot reducer dot main, r is capital, e dot reducer dot main function. Okay, reducer dot not main function, we just we put here the all of the summation of this water body. Okay, that's why we use here the instead of main function we use here the summation function. That means summation function sum all of the water body or lake water body we calculate. Okay, so what is our geometry? Geometry is our study area, ROI. Okay, and also scale size of the satellite data set, scale factor, scale factor, sorry, scale factor we put here the 30 meter. Okay, since CRS not needed, transform is not needed, we base debug, max pixel we also we max pixel we remove from here. So now we see here all of the things we calculate, and also we print it. Okay, we print this function. So print function and print what is print, we like area we print, and now we see as the object. Okay, now we see when you click the run, see here the object in dictionary is computing. Dictionary is computing is this study area, this water body. Okay, this water body area show as a square meter. Okay, this water body show as a only square meter. Okay, so this water because this function, when if you want to check this function, just click copy and paste in our docs tab, because docs tab your friend as all of the function available docs tab. It is generate an image with a value of the each pixel area, that pixel square meter. Okay, this value show as a square meter, and the return image has a single band called area. Okay, so that means this function automatically calculate your water body as a square meter. Okay, if you want to convert this unit, suppose square meter to square kilometer or hectare. Okay, just you convert it. Okay, just you convert it. For that, so wait a minute. So after some time we will convert this value. Okay, so as pixels area, just we convert it as a square meter to a square kilometer or a square hectare. If you want to see here the square meter, to just search as square meter to a square kilometer. Okay, you see here the when square meter, and when you want to square meter to kilometer, just you divided um, by the 10 to the power 6. Okay, 10 to the power 6, that's automatically it converted is a square kilometer. Okay, so now we apply this technique here. So we use the divide function, divide function, and 10 to the power 6, 10 to the power 10 is 6, that means 10 to the power 6. Now this value automatically show as a square kilometer. Now click the run, and now check the dictionary. This dictionary show as a square kilometer area, 0.179 square kilometer of this lake area, or this is a small part of the lake area. Okay, small part, that's why this study area see as a of 0.19179 square kilometer. Okay, this is the way. If you want to get the value, eh, not only object direct show in a value, just you take another variable name is value. Okay, and also we put here the call the lake area, simply copy and also paste here. Then we use the values function, and also we use here the values function. Then we put here the get. Okay, get information. So get information, who is get, we want first item back in this is a JavaScript language. G0 indicate the first item, and also this G0 indicate the first item, and also this value show as directly. Okay, now click the run, and now also we use here the print function. Okay, print function, and this is the values. Okay, and values. Now click to the run, and also you see here the directly computed object. You see here that this value directly show as this value. Just of object, when we expand this object, you see this value, and directly when we use the values function and get information first function, directly we see this information of the 0.19. Okay, 0.179 square kilometer. Just we print this with the headline name. Let's say is lake shape file, lake shape area square kilometer. Okay, square kilometer. Just we put this headline and try to print. Now click to the run, and now you see here the this headline show as a lake shape square kilometer. This is the value 0.1974 square kilometer. Okay, so this is the technique for your any study area. When you want to estimate the any water body area calculation, or estimate the any lake shape file calculation, use this technique and apply it. Okay, So thank you, thanks for watching.